Hello coax, my name is Jaden Vimani and this is the final submission video for Team Benny and the Jetson TX2. My real experience began when I was 15 and I started building projects like a racing drone that was made from an Arduino, or a drone whose motors could be turned on and off with the motion of a color marker, or even some computer vision based projects such as when I replicated the superhero Daredevil's abilities for a Google event. Those projects helped bring me even further, such as when I won the L3 Westcam Hackathon for making computer vision drones, despite being the only one under 18 at the event. More significantly, in the summer of 2019, when I worked for Air Matrix, a Toronto-based startup building aerial highways for package delivery drones. More specifically, I was responsible for building the emergency landing systems for all drones on our network in case of a failure, as well as building the Ross Gazebo simulation environments, which they're still using today. My project for CopterHack 2020 is a drone that can navigate indoor retail stores and make sure that a vendor is getting their fair representation for the price they paid. Now, initially I entered with the idea of a drone that anyone could use to deliver a package to a specific location just by clicking on it. I initially pitched it in December because I thought it would be good for people who are stuck in COVID lockdown and are being failed by most of the standard parcel companies. For that initial idea, I went as far as to build a drone without a GPS that could go anywhere that a user clicks on a map, link in description. But it wasn't until after that I realized that the market for people who wanted package delivery drones and who could actually afford them was really small. Not to mention the fact that the packing shipping industry right now is way too overcrowded because of the number of people who had the same idea I did. But in about January, I started realizing a big problem with the retail industry is that a lot of brands are often cheated out of a proper representation and thus sales in actual stores. The way most retail stores work is that brands pay for space on a shelf. Such as if Coke was buying space at a convenience store, they pay in order to get more representation in order to boost their sales. But the actual keeping track and maintaining of said representation on the shelf is left up to the employees of the store itself, which can cause a lot of problems. Just a 3% boost in representation can boost a brand's sales by up to 8%. But usually in the US and Canada, a brand is given less than 85% of what they paid for on a shelf. If that wasn't bad enough, when a brand makes promotions in a store to, say, promote a new product, up to 60% of that is usually forgotten by employees, which kind of makes sense. It's not exactly part of the job to be advertising for this one company. There's a lot of companies like Intellect who use things like computer vision to manually scan a shelf in order to make sure a brand is getting its end of the deal and making sure it's getting actually represented. But my problem with that is that it doesn't really solve the problem. Which got me thinking, if an employee's ineptitude in properly putting up representation for a brand is causing said brand to lose up to 25% in sales, what if you could take the employee out of it? What if there was a way for a shopkeeper, at the end of the day, once everyone is gone, to just press a button and have a drone fly around and complete their entire store check within 15 minutes, and then have that data sent automatically back to the vendor and make sure things are going right on both ends of the transaction. If this drone was guided by something like, say, an article marker, then it could automatically fly around the entire store while avoiding any unanticipated objects and to a bunch of different checkpoints. And if one of those checkpoints wasn't there or wasn't as large as it expected, then it could automatically relay that information back to ground station, which could be relayed to an online web database, which could be shown to anyone on the other side, say a brand vendor. That is the basis of my CopterHack project. I've modified the existing Clover article marker detection script while running a bunch of computer vision, such as edge detection or contour detection on top of it to detect and avoid any obstacles that it might encounter in the way. This script allows it to detect an article marker, any article marker, and center itself on it. It then finds all contours that are less than a certain size surrounding the marker. It then filters out the box surrounding the marker and counts the number of contours around it, which in this case would represent the number of a certain brand. Now once that's counted, it sends that back to the server and moves to the associated direction to the next article marker, which would be associated with another brand. While it's in transit, i.e. not directly looking at one marker or another, it uses edge detection plus optical flow to identify any objects in its path. And should an article marker not be detected on those objects, like it's not an object that it's supposed to be scanning, then it uses the area of the contour to determine the best way to avoid it and takes that action in order to, not crash. This is what the script looks like in action. So this is a shot from my drone's POV. And you can see that as soon as I move an article marker in front of it, it's being sent instructions as to how to have that article marker centered in frame. Now, once the article marker is centered in frame, it identifies the ID and adds it to a list of IDs that have already been read. Now, what it's doing is constantly looking for one specific ID because that's the endpoint. It's assumed these are being placed in series, like 136, 137, 138. And its eventual endpoint is to get to one specific marker. Now, in this case, the marker I just showed was 137. Now, this one I'm bringing up now is 138. Now, that is the eventual endpoint of this series. So, again, it's being sent instructions as to how to have it stabilize and frame. Now, the difference with this one is that you can see that green boxes are being drawn at objects around the marker. Now, those are representative of the of objects that have been detected around it. So, in the case of a retail store, it would be like the number of boxes of a certain brand. So it counts those contours while ignoring the contours drawn by the article marker, which you can see are highlighted in blue. And then once it does reach the ID, because again, it's always looking for ID number 138, it's sent instructions to land the drone, which are basically just say, stop the program, we've counted all the items right now. And again, now I'm moving my hand, and you can see that, again, it's using optical flow to detect my movement. This is what it looks like in action, and it's important to note that in this case, the article marker on the left is number 137. That's the one it's looking for. And the one on the right is number 142. Now, so what it'll want to do is that once it identifies 142, it'll want to go left to find its destination, which is 147. So again, it's finding the contour, centering in its frame, while constantly keeping track of the objects around it, which it's noting as the bricks on the wall. So again, it finds it, it centers it in frame, then it lands because it's reached its final destination. So this right here is a second field test. And again, the one on the left is number 137, and that's its target. That's the one it's looking for and is the one it's always going to want to go to. So again, once it takes off, it notices our mark number 142, which is shown here, while noting the objects around it as the bricks on the wall. But you can easily see that with, like, cereal boxes or cans of Coke of a certain brand. So again, it goes to number 137, and the wind was throwing this one off a bit, so it landed a bit off target. But regardless, it was still tracking the article markers and tracking the surrounding contours at the same time. My biggest hiccup throughout this project is that because of my large pivot halfway through, I wasn't quite able to finish the graphical interface. So any information that's conveyed to the user, that I conveyed from the drone to the ground station, is limited to terminal output. My next big change would be to the ground control station. For this example, this ground control script was run from my laptop, which was connected to the drone's network. But what I would like to do is have a Flask web server running on a Raspberry Pi, which when it got a request, say from a user's phone when they wanted to do end of the day checkup, then it would have a dongle to connect to the shop owner's network so they could actually receive that request, and would be connected to the drone's network at the same time so that it could automatically get the request and run the script in order for the drone to conduct a scan properly. In the future, I see coax playing a large part in making this project more compact and versatile. Not only would the Clover be a great drone for production because of its relative lightweight and increased safety, but having a swarm of Clovers would be an excellent way of covering large retail shops or large areas of space in a relatively short amount of time. If each drone was assigned a specific section of the store, i.e. a certain number of article marker IDs to pass, then the entire scan could be done in a fraction of the time, and the owner could have all the information about the store relayed to them through their cell phone all at once. Each of those drones could also individually be connected to that Raspberry Pi web server I mentioned before, which would in turn be connected to the user's phone, which would allow them to monitor the progress of the scan by updating the article marker IDs that each of the drones has covered, and also would allow them to intervene in the case of an emergency. As said before, my main skill is computer vision, and I think with coax's intuitive hardware design, and as said before, my main skill is computer vision. I think with the help of coax's intuitive hardware design and their advanced understanding of drone control, retail management and brand recognition doesn't have to be such an arduous task anymore.